Hi everyone. Today we're going to be solving the HMMT 2019 Algebra and Number Theory Test, Problem 3. Among all polynomials p of x with integer coefficients for which p of -10 is equal to 145 and p of 9 is equal to 164, compute the smallest possible value of the absolute value of p of 0. Okay, so let's begin. So let's just do a side note really quickly. So we can prove that we can take the example that a minus b for any integer values a and b is divisible by, so they're divisible by p of a minus p of b. So let's just take an example, p of x. And let's just give it 2x squared plus 3x minus 5. So these have integer coefficients, which are part of the constraints of this question. And let's just say we have a is equal to 7 and b is equal to 5. Then we have 98 plus 21 minus 5, which is equal to 114. And then 25. 50 plus 15 minus 5, which is equal to 60. So then we have 7 minus 5, which is equal to 2, and 2 is divisible by 54. 54 divided by 2 is equal to 27. And you can use any different polynomial and any a and b values, and you can see that the this is consistent. A minus b is divisible by p of a minus p of b for any polynomial with integer coefficients, and a and b have to be integers. Okay, so let's go on with that assumption, with that proof. So we have p of 0, which is what we want to find. They gave us p of -10, which is 145, and p of 9 is 164. So we want to find the smallest value of the absolute value of p of 0. So we have to get p of 0. So 0 minus -10, and then the divisibility of p of 0 minus p of -10. So that means 10 must be divisible by p of 0 minus p of -10. And then the same thing for 0 minus 9. So -9 must also be divisible by p of 0 minus p of 9. So that means that a must be congruent to some number mod 10, which is for this, it has to pertain to this p of -10 is equal to 145, and a must also be congruent to a value m mod 9, which pertains to this um, equivalence as well. And you can find out that n is equal to 5 because 145 divided by 10 is equal to 14, remainder 5, and m is just equal to 2. Okay, so now we have to utilize the Chinese remainder theorem to solve the rest of this problem. So a is congruent to 5 mod 10, and a is also congruent to 2 mod 9. So you can either use the Chinese remainder theorem, or you can just try out different values, test some values. But if you know the Chinese remainder theorem, it should be pretty easy to solve it. So you just have to get d1, d2 is equal to 90, the 10 divided by 10 times 9 divided by 10, which is 9, and then this is 10. Then we have to do 9y1 and then 10y2 congruent to 1 mod, and then that same modular, and then this is 1 mod 9. And then you can solve this. This is just y2 2 must be equal to 1 because 10 is equal to 1 mod 9. And then y1 is equal to 9 because 9 times 9 is equal to 81, divided by 10 is equal to 8, remainder 1. So now we just have to do a little multiplication and addition. And so you just have to do 5 times 9, which is equal to 405, plus 2 times 10 times 1, which is equal to 20. So that's 425. And we do this all mod 90. And we can just simplify this and we get 65 mod 90. So this is the smallest positive value that we can get. But remember, we wanted the um, smallest absolute value. So it can also be negative, but so let's just see what the smallest negative value would be. So 65 minus 90 is equal to negative 25 mod 90. So these are both congruent. 65 is congruent to negative 25 mod 90. And this is also the smallest p of 0 we can get. And therefore, the answer to this problem is simply 25. 25 is the smallest possible value of p of 0. So that is the answer to the HMMT 2019 Algebra Test, Problem 3. So I thank you for watching and have a nice day.